Good day, learners. My name is Mashidu Mamburu. Today we'll be doing technical science. Topic is organic molecules. We have the introduction. Under introduction, we are saying this learning area is methane materials, organic molecules. It has 54 marks in paper 2. And we are saying organic chemistry is very much important because it makes up a big part of our own bodies. They are in the food that we eat, in the clothes we wear. They are also used to make products such as medicine, plastics, washing powders, dyes, along with a long list of other items. So that is very much important for us to do organic molecules. So it will have 54 marks, which is 36% of paper 2. The objectives of this lesson. At the end of this session, learners, you should be able to define organic molecules, define homologous series, define functional group, define hydrocarbons. Under hydrocarbons, you must be able to define saturated hydrocarbon, unsaturated hydrocarbons. You must be able to define isomers, which are the chain isomer, positional isomer, and functional isomer. Lastly, you must be able to define primary, secondary, and tertiary alcohols. So you can see that it's very much important that we are able to know all these definitions. So I'll try to make it a point that I simplify how you go about defining so that at the end of the day, you are able to do all these definitions. Under this section, we will do 9 different homologous series. For technical science, there are 9 examinable homologous series, which are alkanes, alkenes, alkynes, haloalkanes, alcohols, aldehyde, ketones, carboxylic acids, and esters. So these are the 9 homologous series that we do for technical science in grade 12. However, there are many other homologous series that we don't do. So we only focus on these 9. For each homologous series, you need to know the functional group. For each functional group, you must know the name of the functional group and the structural formula of the functional group. Number 2, you must be able to know for each homologous series to write down the molecular formula, structural formula, and general formula. You should be able to identify compounds up to 6 carbon atoms in the parent chain that are saturated or unsaturated. So what we are saying here is, for technical science, you do only 6 carbons, not more than 6 carbons. So we are limited only to 6 carbons in the parent chain. So all our structures will be up to 6 carbon. Now, as we move to our lesson, the first thing that we must know is the definition of organic molecules. You must first know what is this organic molecule. Organic molecules are molecules containing carbon atoms, meaning that carbon is going to be at the center of our lesson. But it doesn't mean that all compounds that have carbon, they are organic molecules. For example, you have carbon dioxide, which is not an organic molecule. So we got to know that there are exceptions, but majority of carbon-containing molecules, they are referred to as organic molecules. Now, each carbon, what we must know is that each carbon must be surrounded at all times. It must be surrounded by 4 carbons, 4 bonds around it. So we are saying at all given material, our carbon will be surrounded with 4 bonds around it. So at all the times, ensure that you check how many bonds surround a carbon. This is very much important because the whole of this study will be dealing with that. And you don't have to make a mistake of writing less or more than 4 bonds around each carbon. So all the time, we're saying carbon can only be surrounded by 4 bonds. Carbon can bond to form straight chain and branch chain. So we're going to do what we refer to as straight chains and what we refer to as branched chains. So there will be 2 chains that will look at straight chain and branch chain. Because of this, they can form long chain structures that can be formed because of these carbons. So that is the main aim of our lesson. So at the center of our study is your understanding of carbon. To say carbon can form 4 maximum bonds around it. Now, as we move forward, we are saying, let's look at homologous series. Remember, I said there are 9 homologous series. For the entire study, for that 54 marks, it's all about these 9 homologous series. So let us be sure that you know all these 9. Now, what is a homologous series? A homologous series is a series of organic compounds that have the same general formula and where each member differs from the next by CH2. So when you define homologous series, there are two things you look at. You are going to look at this general formula is the same, and what is different is they all differ by CH2 from one to another. So let's have that understanding of saying that when you define homologous series, you'll say it's a series of compounds that have the same general formula and where each member differs from the next by CH2. Remember, learners, when you are doing definitions, ensure that you have all your keywords in the definitions and use exam guidelines. So we're saying for all our definitions, we're going to use exam guideline. So you won't use any other source except exam guideline and CAPS document. So your definitions will be the same way they are written in the exam guideline and in the CAPS document. So the first definition we talked about, we said is a homologous series, which we said is a series of organic compounds that have the same general formula and where each member differs from the next by CH2. We said we have 9 of them. So look at them. They are in this way to say the 9 homologous series that we are referring to. The 9 homologous series that we are referring to, I say AAA, Hig, AC, just for you to be able to remember these 9. To say we have alkanes, alkenes, alkynes, these 3. Then we have haloalkanes, we have aldehydes, we have ketone and esters. Then we have the last 2, which is your alcohol and your carboxylic acid. So those are the 9 homologous series that you are supposed to know. As I indicated that for each of these 9 homologous series, you are supposed to know, number 1, the functional group. The question is, how will I differentiate between alkanes, alkenes, alkynes? How will you differentiate between them? How will you differentiate haloalkanes? You can call them haloalkanes, or you can call them alkyl halide. Alkyl halide. Then we have aldehyde, we have ketones, we have esters, we have alcohol, and we have carboxylic acid. So these are the 9 homologous series that you will do under organic chemistry for both question 2, question 3, question 4, and some few questions in multiple choice questions. Now, we are saying for each of these, you must know their functional group, which means we're going to look at the functional group for alkanes, for alkenes, for alkynes, for all the 9 homologous series, because that's how you will differentiate between them, using their functional group. This next thing, for all of them, you must know their general formula. All of them, they have general formula. So that is the second thing you must know. The first thing was saying functional group. The second thing was saying general formula. Then another formula that you must know is a molecular formula. The last one is the structural formula. Now, what we got to understand here is that a molecular formula is a chemical formula that indicates the type of atoms and the correct number of each in a molecule. I will give you examples as we go on of a molecular formula and of a structural formula so that you are able to understand. So we're saying a structural formula is a formula of a compound. It shows which atoms are attached to which within a molecule. It shows all bonds. So what is important? We are saying for molecular formula, we are saying what you are supposed to do. It will show you how many carbons you have and how many hydrogens you have. Then we'll refer to that as a molecular formula. But when you say structural formula, it changes now. You show all the bonds, which means you'll write a carbon. We said carbon can form maximum of four bonds around it. So we'll write a carbon with 4 hydrogens around it. Then that we know is a structural formula. So we are saying for all these 9 homologous series, you are supposed to understand their general formula for all of them. And then number 1, general formula. Number 2, molecular formula. Number 3, structural formula. So there are 3 formulas that we are supposed to understand for technical science in grade 12. So we're saying for each of the homologous series, you will know general formula and how to write the molecular formula of all the molecules and how to write the structural formula of all the molecules. Now, as we move now, we are saying for naming of these organic compounds, because remember, we are only going to do up to 6. We are only going to do up to 6 longest chain. So 6 carbons is the maximum number of carbons, which means the longest chain must have from 1 to 6 carbon. Now, when we give the name of organic compounds, we're going to derive the name from the number of carbon atoms that it has. For example, if the longest carbon chain is 1 carbon, the prefix of the name will be meth, as indicated. So meth is for 1 carbon. You know that already we talked about the number of hydrogen bonds around it, meaning that if it's 1 hydrogen carbon, it must have 4 bonds around it. If we have 2 carbons, then it will be like that. And ensure that the number of bonds around each carbon, they are 4 at all the times. If it's 3 carbons, the name will be prop. If it's 4 carbon, the name will be but. If it's 5 carbon, the name will be pent. If it's 6 carbon, the name will be hex. Remember, as we move to all the homologous series, we are moving carrying this weapon that we are having here, which is our prefix, which we find on the number of carbons. So the number of carbons, already they will tell us how the name will start. We move without wasting time. Yes, sorry for that. Now we move to the next slide. Here we're going to talk about hydrocarbons. Hydrocarbons. As the name says, hydrocarbons, you can see it's a hydro, which is taken from hydrogen, and carbon from the word carbon. So these molecules that are called hydrocarbons are organic molecules. It's very much important as you are giving the definitions to start by naming that these are organic molecules. So these are organic molecules made up of hydrogens and carbons only, which means hydrocarbons, they are made up of hydrogens and carbons only, with the keyword there being only and hydrogen, carbon, and only. So you can't omit one of those 3. If in the definition, for example, in the exam, you write organic molecules made up of hydrogens and carbons, you won't be able to be awarded the mark because you omitted only. So you must be able to indicate only, because if I write a structure like this one, organic molecule like this one, with OH, for example. I'm just giving an example. If I write a structure like that one, you will have seen that in that structure, this structure is made up of hydrogens and carbons. So if you say hydrocarbons are made up of hydrogens and carbons, you don't write the only part. It means you have omitted, because even alcohols, they are made up of hydrogens and carbons. So it's important that when you define hydrocarbons, you indicate that they are made up of hydrogens and carbons only. The only part is closing any other atom that cannot be included. So that is very much important. The definitions, you must understand and know all of them. Now, these hydrocarbons, we have 2 hydrocarbons, which is our saturated hydrocarbon and our unsaturated hydrocarbons. So you got to know that hydrocarbons, we have 2 of them. The saturated, as the name starts with S, it indicates that saturated hydrocarbons, they contain only single covalent bonds between carbon atoms. So they have only single covalent bonds between carbon atoms. Those are our saturated. So for saturated, understand saturated, S, start with an S. Remember, saturated is only single bonds. So we're saying all saturated hydrocarbons, they have no double bonds, they have no triple bonds. They have single bonds between carbon atoms. The keyword there as well is these single carbon-carbon single bonds are between carbon atoms. So there's an example of an alkane that we are having. We are having here for us a structure given there under alkane. So for saturated hydrocarbons, we have alkanes. For unsaturated, we have two unsaturated hydrocarbons, which are your alkenes and alkynes. How do we define unsaturated? We're saying they contain covalent double or triple bonds. So they have carbon-carbon double bond or carbon-carbon triple bond. So it's very much important to ensure that as you understand your alkanes, we're saying alkanes, they are saturated because they have carbon-carbon and carbon-hydrogen single bonds. Whereas alkenes, they are unsaturated because they have carbon-carbon double bonds. And alkynes, they are unsaturated because they have carbon-carbon triple bonds. So this is the fifth definition that we are doing now. Remember, we've done homologous series, we have done hydrocarbons, we have done saturated hydrocarbons, we have done unsaturated hydrocarbons, and we define organic molecules as we start. So we're saying it's important for you to understand that hydrocarbons are made up of hydrogens and carbons only. As I complete, they are either saturated or unsaturated. We are saying that saturated, they contain only single covalent bonds between carbon atoms, whereas unsaturated, they contain covalent double or triple bonds. As you have seen with alkenes, has double bonds, alkynes have triple bonds. So all these three, the alkanes, alkenes, and alkynes, we refer to them as homologous series. Remember what we said when we start? We said homologous series, they have the same general formula. So meaning that all these alkanes, they have the same general formula, which is CnH2n plus 2. All alkanes have the same general formula, which is CnH2n plus 2. As we move, this slide will simplify alkanes, alkenes, and alkynes for us. So we're saying when we have one carbon, the prefix of the name is meth. Now, the name of the homologous series is going to give us the suffix. Remember, prefix, we're referring to how the name starts. We're referring to how the name starts with the prefix. And when we refer to suffix, is how the name will end. So we're saying the number of carbons in the longest carbon chain give us the prefix, how the name starts. But the homologous series, which is defined through the functional group, it gives us the suffix, which is the name ending, to indicate how the name will end. Let's look at that now to say, when you have one carbon, you will know it's meth. I'll be writing this side to say, if we have one carbon, we know that this is meth. Because these are hydrocarbons, obviously, we're going to have 4 hydrogens. We said maximum of 4 bonds around each carbon. Now, if we have 2 carbons, we're going to have a structure like that. Now, we said when we have 2 carbons, it's now eth. 2 carbons is eth. You are checking how many carbons is 1. You know that is meth. When it's 2 carbons, you know is eth. When it's 3 carbons, which I'll do in the next page, when you are having 3 carbons, you will know that the name will start with prop. So that's what you are going to be looking at to say in organic molecules, we use the number of carbon in the longest carbon chain for us to get our name. So when it's 4 carbons, we said it's but. When it's 5 carbons, we said it's pent. When it's 6 carbons, we said it's hex. So it's 6 carbon. 6. So when you have drawn like that, all you have to do now is to look for the hydrogens. Remember, around each carbon, there must be 4 bonds. So you must, as you are putting the hydrogens, you must count the number of bonds around each carbon. So this carbon already has 1 bond, so it will be 2, 3, 4. So you know that carbon is surrounded by 4. This one is surrounded by 2, so you will have something of that nature. So you always, when you draw your structural formula, you always refer back to, you count the number of bonds around each carbon. Because if in the exam you make a mistake of writing more than 4 bonds around the carbon, you will be penalized and you will get the answer wrong. So those are the 6 that we do. So for alkanes, we said it gives us the suffix. The suffix is A-N-E. So we are saying the suffix is A-N-E at the end of the name. The number of carbon gives us the prefix. So we know when it's 3, 1, 2, 3, the prefix becomes prop. Because there is no double bonds, it's only single covalent bonds for alkanes, then you will know that this one is propane. So that's how you will know. You are putting, this one is the number of carbons, this one is the homologous series. Now let's move. When you want to move from alkanes now, you want to move to alkenes. You will see that for alkenes, which is what we are having here. For alkenes, what we are going to do is that you are going to have, remember meth, we said is 1 carbon. 1 carbon, we said is meth. So on this slide, we said alkenes, they have carbon-carbon double bond. So you need 2 carbons to have a double bond because the double bond must be between 2 carbons. So you can't have an alkene with 1 carbon because you need minimum of 2 carbons to have an alkene. What is going to happen is that you're going to have 2 carbons. So it means when it comes to alkenes, they only start from ethene. We don't have methane because methane has only 1 carbon, but ethene, you'll start from ethene going forward, which means we'll have ethene, which will be like that. I said all the time, let's check the number of bonds around each carbon. So you'll have 1, 2, then you must have 3, 4. 1, 2 for this carbon, 3, 4. So at all times, you ensure that each carbon is surrounded by 4 bonds around it. So it means we'll have ethene, then as you do 3 carbons, you'll have now what we'll refer to as propene. These will refer to as propene. Remember what I said, count the number of bonds all the time. So obviously, this one, it has 1, 2, 3, 4 bonds. So you can't have another hydrogen there. So what will happen is that you'll have 3 hydrogens coming there. So this now becomes propene, because 3 carbons from our slide here, we said 3 carbons tells us that is prop. Then we look at the double bond. The double bond tells us that it's an alkene. So we take the suffix. The suffix for alkenes is "in" at the end of the name. So hence we are writing it as propene. There is something very much important when it comes to, so we're saying alkanes, we have methane, ethane, propane, butane, pentane, and hexane. We do only up to 6 carbons. But when it comes to alkenes, we said we don't have an alkene with 1 carbon because the carbon-carbon double bonds must be between 2 carbons. The carbon-carbon double bonds must be between 2 carbons. So our alkenes, they start from ethene. We'll have ethene, butene, pentene, hexene. So we'll have 5 of them that we do for technical science. As I indicated that we do only up to 6 carbons. However, I will want to explain something to say, let's look at the structure of butene. I'll write the structure of butene. That will be our structure of butene. Why is it butene? We're saying you count the number of carbons is 1, 2, 3, 4. We said when it's 4 carbon, it's but. So you are able to know that when it's 4 carbon, it's but from this key that we are having, carrying from here. When it's 4 carbons, we said it's but. Then we look at the position of the double bond. The double bond is in carbon number 1. So we'll call it but 1, in. In, we know, is the suffix for alkenes. But is the prefix which we got from the number of carbons in the longest carbon chain. So we have but 1 in. However, this but 1 in that I'm referring to, we can move the double bond to carbon number 2. So meaning that the name will change. If we move the double bond to carbon number 2, the name will change to become but 2 in. So we have but 1 in, depending on the position of the double bond. So if the double bond is in carbon number 2 now, you see this is carbon number 1, carbon number 2, carbon number 3, carbon number 4. When it's 4 carbons, we say this but. Then you look at the name to say which name is it? Which name is it? So we are saying is but. The double bond is in carbon number 2. See how I'm writing the numbers. Immediately when I introduce the number, between the alphabet and the number, I'm putting a hyphen. So at all times when we're doing the naming, ensure that between the number and the number and the alphabet, you put hyphen. So but T is an alphabet. I must put a hyphen. Then I indicate the number which is 2. I indicate the number which is 2. Hyphen 2 is the number where we find the double bond. Then I'll say 2 but 2 in. So it's indicating that the double bond is in carbon number 1. On this one, the double bond is in carbon number 2. So that's what changes when we do from butene, pentene, going forward. So that's why we indicated here that for ethene, you just write ethene, then you have propene. But when you go to but, you'll have but 1 in and but 2 in. However, you can't have but 3 in, because if you put the double bond on this carbon becomes carbon number 1. So when you are numbering, you always number from where there is a functional group. Where there is functional group, that's where you will start numbering. So you can't say this is but 1 in, then when you put the double bond here, you say is but 4 in or but 3 in. You can't say that. We don't have but 3 in or but 4 in. When you start numbering from that side, it will simply mean that the numbering changes. You will number from this side where there is a double bond, which means in our numbering now, we will say carbon number, we'll say this is carbon number 1. We'll say this is carbon number 1. Number 1, number 2, number 3, number 4. This is very much important to say when you are numbering your longest carbon chain, you number from where there is a functional group, closest to the functional group. The functional group, when it's this side, this becomes carbon number 1 in that fashion. Now, as we move forward, so we are saying here for butene, you'll have but 1 in and but 2 in. If the same applies for pentene, you will have pent 1 in and pent 2 in. Then for hexene as well, you'll have those other structures. Now, these hydrocarbons that we're talking about, they can be unbranched, they can be branched. So there are times when we have a branch, there are times when we don't have a branch. So what we are saying here is, let's look at this one, is 1, 2, 3, 4. You know that when it's 4 is but, then you're going to say, okay, because there is 4 carbons, that is going to give us but. It's going to give us but as a prefix. Because now, here is a carbon-carbon single bond. There is no double bond. We know those are alkanes. So you will refer to this as butane. The but from the number of carbons, the ane from the homologous series, how the homologous series end. Now, when we move here, still, this is unbranched, but we have a double bond. So you are going to say, okay, you count, you say 1, 2, 3, 4. Still, because it's 4 carbons, we'll say but we have a double bond. When we have a double bond, we use hyphen. So where do we find the double bond? In carbon number 2. So this will be but 2 in. Always when there's a number and an alphabet, we put hyphens. We combine numbers and alphabet with hyphens. So we move as well to the third one there. You can see the longest carbon chain is 1, 2, 3. So you will have seen then that we're having 1, 2, 3, 4. So we have 4 carbons as well. 1, 2, 3, 4. So now what is happening? Because it's 4 carbons, the longest carbon chain is 2. But now in our numbering, we numbered closest to the functional group. Now it's no longer, it's now triple bonds, which means triple bonds is alkynes, which means our name will end with wine at the end of the name. So this will be but. In carbon number 2, we have a triple bond, which is a wine. Then we don't forget to say but 2 wine. So at all times, you know that we always check where our triple bond is when we are naming. Then when I say but 2 wine, you are able to know that in carbon number 2, you will find triple bonds. These hydrocarbons, they can as well be, they can be branched. They are not always straight like that from 1 to 6 carbons. They can have branches. Now, that's why we are saying now here, when we are having branches, these branches can contain 1 carbon, and they can contain, single bonds, carbon-carbon single bonds, carbon-carbon double bonds, and carbon-carbon triple bonds. So we got to know the difference there. Immediately, when you find a structure like that one, you will know that this is branched chain. This one indicates unbranched. Unbranched alkane, unbranched alkene, unbranched alkyne. Then we have branched that we have there. We'll do it now as we're doing naming. Now, remember, we said, let me take you through what we have done so far. We said we look at the number of carbons. The number of carbons tells us the prefix of the name. The number of carbons give us the prefix of the name. We said we do only up to 6 carbons. We said depending on the homologous series. If it's an alkane, it will give us the suffix. Suffix comes from homologous series, whereas prefix comes from the name of the prefix comes from the number of carbons. So all you do, you are counting the numbers. If 1 is mid 2 in that fashion, you do like that. We said all these 6 alkanes, they can have branch. They can have branch in them. Those branch, we refer to them as substituents. Substituents, or you can refer to them as branch, or you can refer to it as a side chain. So we're saying when you have a long structure, but it has a branch. Now we're going to check how are we going to know, because already you know that for all of this, you look at the number of carbons, you look at the homologous series, it will tell you what is the name. But now we are saying when you are having a long carbon structure and a branch in them, how are you going about naming them? So we refer to those as substituents, branch or side chain. For technical science, you only do 2 substituents or 2 branches, which is your CH3, which is methyl. Remember when we started, we said CH4 is methane. We said C2H6 is ethane. You remember we talked about that. Now, when you look at this, it's CH3, which means it's a methane that we have removed 1 hydrogen. So it becomes CH3. So when it says CH3, we refer to it as methyl. So we now refer to it as an alkyl group. Why is it an alkyl group? Because we remove 1 hydrogen from alkane. So when you're having methane, you remove 1 hydrogen, it becomes methyl. It's no longer methane, it's methyl. When you are having ethane, which is C2H6, when you remove 1 hydrogen, it becomes C2H5. It's now referred to as ethyl. Ethyl. Now we're going to use it in a name to see whether we understand this one or not. Let's look at the structure that we're having here. The longest carbon chain that we're having is 1, 2, 3, 4, 5. You can see all the time I'm counting the number of carbons when I start. Because immediately when I know that we have 5 carbons, I know that the root of the name or the prefix is pent. So I know that that is my pent. And there is no double bonds here. So I know that because there is no double bond, is alkane. So it will be pentane. Pentane for alkanes. Now, in this pentane, we refer to this as a parent chain because we get it from the longest carbon chain. So we say we have pentane. But we have a substituent now that we're talking about, which is now C2, 2 carbons, and 5 hydrogens. We know that is ethyl. Ethyl. So we refer to this one. C2H5 is ethyl. So we know that we're going to look at the position of the ethyl to say ethyl is in carbon number 3. So what you're going to call now, you'll say this is 3-methyl pentane. 3-methyl pentane. So you are saying the methyl group is in carbon number 3. So when you look here, you will see that in carbon number 3, you have the methyl group. Now, without any wasting of the same will apply when you move to your alkenes and your alkynes. So you'll always number the longest carbon chain, which is still 5. So it will be pent. The parent chain will be pent. Then you check where the double bond is in carbon number 2. You'll say pent 2 in as your parent chain. Then you go and look for a substituent. You see now in our naming, we're always starting with the substituent. Then after our substituent, we write the pent, which is our root, the prefix of the name that we're having there, which is our root. Then the suffix, which is how the name ends. So you will see that you always write the substituent first. But when you write the substituent, you indicate the position where we find the substituent. So we're saying 3-methyl pentane is telling that in a structure of pentane, in carbon number 3, we have replaced a hydrogen with 3-methyl. So in this case, it will be 3-ethyl because this is 5 hydrogens. So it will be 3-ethyl. So this will be 3-ethyl pentane. So you know that is that. When you are checking the longest carbon chain, it's important that you check any possible longest carbon chain that you can have. So on this one, we're saying in carbon number 3, we have an ethyl as well. So it's 3-ethyl pent 2-ene. So always, you know, that is a parent chain. That is the substituent. So in the name, you are always starting with the position of the substituent. Then you write the root that we got from the longest carbon chain. Then you write the suffix that is from the functional group. Now we got to move. If we are having more than one, methyl, for example, you will refer to them as di. If there are 2 methyl, you'll say dimethyl. If there are 3 substituents that are methyl, you'll say trimethyl. In that fashion, trimethyl. But always indicating the position. I've shown the example here. You can have what we refer to as 2-ethyl butane. You can have 3-ethyl 2-methyl hexane. So what is important here when I'm talking about the structure of 3-ethyl 2-methyl hexane is to say the ethyl and the methyl, they must be in alphabetical order, meaning that you can't write methyl before ethyl because E comes before M. That's why even if ethyl is in carbon number 3, you will start with it. So it's very much important when you are doing naming to understand that. Now, we're going to do naming of hydrocarbons. In that one, I was just explaining so that you understand that we have 3 hydrocarbons, alkanes, alkenes, and alkynes. Now, under naming of hydrocarbons, we are saying you will have branched alkanes, which consist of alkyl group. They form chain isomers. So we'll talk about chain isomers as we finish. Now, without any wasting of time, when you are naming, what you will do, you will first recognize. Hence, I did this short for you so that you can remember. I tried to make it easier so that you remember how to go about naming. So for naming of any organic molecules, as the one that we are given here, the first thing you will recognize the functional group to say, what is the functional group here? When you look on this structure, you will see that this structure is carbon-carbon single bonds only. There are no double bonds here. So you will understand that in this structure, what we are having is single carbon-carbon and carbon hydrogens. You know it's alkanes. So you know that these are alkanes. So the name of the parent will end with A and E. From there, you identify the longest carbon chain. So I've shown you here how you go about identifying the longest carbon chain. Remember, I said here you recognize the functional group. Number two, we're saying you identify the longest carbon chain. Longest carbon chain. From there, you number it. You number the longest carbon chain. So what you do, you'll check. This is 1, 2, 3, 4. This becomes carbon number 1 because it's closest to the substituent, our CH3 here. So when you are numbering, you'll number closest to the substituent or the functional group. That's what we talked about. When you have a functional group, you will number closest to the functional group. When you have a functional group and a substituent, you will number closest to the functional group, then followed by the substituent. So in this case, we'll say this is carbon number 1, carbon number 2, carbon number 3, carbon number 4. You can't say carbon number 1, carbon number 2, because you want to number closest to the substituent. So the closest to the substituent is this becomes carbon number 2. So when you refer to that, you'll say, okay, this is carbon number 2. What do we have in carbon number 2? Hence I said rin. So you recognize the functional group, you identify the longest carbon chain. After doing that, you number the longest carbon chain. So you have recognized the longest carbon chain, you can number it this way, or you can number it that way. So you must find all possible ways of numbering or of looking for the longest carbon chain. When you got your longest carbon chain, you have numbered it, then you're going to look for the position of your substituent or of your side chain. So this is the position. In carbon number 2, we find a methyl because it's only one carbon. So the name will be 2-methyl. The name will be 2-methyl butane. You can see now that what makes this 2-methyl butane is because the first thing, you looked at the longest carbon chain, which is 4. You said 4 is but. You looked at, they're all single carbon-carbon single bonds, which means it's alkanes. It gave you the suffix, which became this ane. You looked in carbon number 2, you find a methyl. Then when you write, you always start with your substituent or your side chain. Then you write your parent name, which is butane. So the name will be 2-methyl butane. Now, we continue with the naming of alkenes and alkynes. You will follow the same steps to say you number the longest carbon chain. Remember, when you're numbering the longest carbon chain, you number closest to the functional group, closest to the double bond or closest to the triple bond. So it must be, hence we are numbering from here, which is carbon number 1, carbon number 2, number 3. Because if you were to start here, this will become carbon number 3, which is wrong, because you ensure that you reach your functional group fastest. Hence, you will number this one from here. It will be carbon number 1, carbon number 2, 3, 4, 5, 6. You know the parent is hex because it's a triple bond, it's a wine. So it's hex 3 wine, the name of that one. Then you look that in carbon number 4, you have a methyl. So you're able to say we have 4-methyl. Because it's 6 carbon, is hex. Because it's triple bond, is wine, which is in carbon number 2. So you know that you will say the name of this is 4-methyl. In carbon number 4, you have a methyl. Then you have a hex because it's 6. So that is hex 2 wine, the wine for the triple bond. You always indicate where you find your triple bond. I think this has helped you in terms of naming of alkanes, alkenes, and alkynes. Now, without wasting of time, let's move to summary of IUPAC naming, because when we are naming all the time, we are referring to this IUPAC naming, which stands for International Union for Pure and Applied Chemistry. Now, for this one, we are always saying prefix, which is, we're always saying you will start by writing the substituent at all the times. You can see all the time I started by writing a substituent. a substituent. After that, you check how many carbons. So if it's 4 carbons, you know it's but. After that, suffix from your homologous series, then you got your 4-methyl butane in that fashion. So this is how you go about naming for your organic molecules in summary. Now, remember we said we have 9 homologous series. We said we have 9 homologous series. Now, here we are having another homologous series that we are referring to as alkyl halides. Alkyl halides, it's number 4. The first 3 we said is alkanes, alkenes, and alkynes, which is said all of them are hydrocarbons. Now, we are moving to the next one, which is our haloalkane. You can call it a haloalkane, or you can call it alkyl halide. So that is the next homologous series that we're having. This homologous series, we get this when we replace, on alkanes, when we replace 1 hydrogen or 2 hydrogens with a halogens. You'll know halogens, group 7 elements, which is your bromine and chlorine. So for technical science, we're doing bromine and chlorine most of the time. So those will be the ones that we focus on. So that will be, when it's bromine as a halide or as a halogen, that is replacing hydrogen, we'll say bromo, which is what we have here. When it's chlorine, we'll say chloro. When it's 2 of them, we'll say di. When it's 3, we say tri. In terms of the naming or of the rules, we use the same rules as we were using for our substituent, the methyl group. Remember, when we had a methyl here, we said the name will be 2-methyl butane. So instead of that, it means if it is a bromo, it will be 2-bromo butane. So we follow the same way that we use to name our alkyl groups as we are dealing with this one. So we're saying alkyl halides or haloalkanes, we are simply replacing 1 hydrogen in the alkane. So that's what we're having here, which is our haloalkanes. Haloalkanes, they have a general formula, CnH2n plus 1x. So we replaced, remember, alkanes, we said the general formula was CnH2n plus 2. Now we're only removing, these plus 2 are hydrogens. We're only removing 1 hydrogen, replacing with chlorine or bromine. And when we write it, we don't write the whole bromine, we write bromo. When it's chlorine, we write chloro. So that's what we are doing here. The example that we are having here is when we are having this structure. You will look at this, hence we are saying alkyl. Remember, I said alkyl is when you are having an alkane. When we remove 1 hydrogen from an alkane, it becomes alkyl. So you can see that's what we have done. We're having 2 carbons, which is ethane. So when you're having ethane, you remove 1 hydrogen, it becomes alkyl. Then it have an halide. Our halide is chlorine. We said when it's chlorine, we say chloro. So the name will be chloroethane. So the name will be chloroethane. The name will be chloroethane. Chloroethane. You see, I'm not worried about the position of the chlorine because if I bring here, it will still be same name. So it doesn't matter whether I say 1 chloroethane. If I say chloroethane, is correct. So that is chloroethane like that. However, if I can have 3 carbons, with a chloro there, when we are numbering, remember we said chlorine as well. We treat it as a substituent like we treat our methyl. So you will start numbering from where there is a chloro in carbon number 1, carbon number 2, carbon number 3. Then you will refer to that as 1 chloropropane. So that's how you go about naming these haloalkanes. The same way you have done when you were dealing with the methyl or the ethyl, the alkyl groups. Now, our next functional group is what we refer to as alcohols. Now, under alcohols, what we are having is that we are replacing a hydrogen with a OH. So the name ending now changes. Remember, we're having methane, ethane, propane, butane, pentane, and hexane. Remember, you were having those 6. So now, when we replace one hydrogen with an OH, the name now becomes methanol. So we're taking the methane from the word methane. We're replacing for alcohol the suffix for alcohol as indicated here. You will have suffix for alcohol, that is your name will end with the OH, OL. For alcohol is this one. So you are having methane with an OH is now methanol. You are having ethane, it becomes ethanol, propanol, butanol. However, from as we did when with alkanes, when you are having propanol, you got to indicate the position of the OH group, because propanol will be 1, 2, 3. Then you have the OH there. So you got from there to start to indicate that the alcohol is in which carbon, because the alcohol can be in carbon number 1, as we are having here. Then you'll say propan, from the word propane. You do the same, the dash, 0, dash, all. This becomes propanol. So you have indicated propan, 1, all. The 1 is indicating the position. The 1 is indicating the position of the OH in the structure. So if the OH is in carbon number 2, the name will be propan to all. So that's how you go about naming your alcohols. The other functional groups, these remaining functional groups that we are having, they are very interesting, all of them. I will do them all at the same time. We have aldehydes, ketones, carboxylic acid, and esters, as written there. All of them, they have something in common. They all have C double bond O. They all have C double bond O. All of these homologous series, they have C double bond O. Now, the difference between them is that aldehyde, the C double bond O is at the terminal carbon, which means at the end of the structure. Like here, we're having the C double bond O with the H. We say this is an aldehyde. And the name of the functional group here, is formyl group. Formyl group. You can say formyl group or formyl group. We have ketones. In ketones, the C double bond O is surrounded by 2 other carbons. So you see the difference between these 4. So we're saying all of them, they have C double bond O. The difference with carboxylic acid is C double bond O bonded to the OH. The esters is C double bond O bonded to oxygen, bonded to another carbon. So all of them, this is how you'll be able to recognize the aldehydes, ketones, carboxylic acid, and esters. All of them, when you look for them, they will have a C double bond O. They have the general formula, which we gave there. So now, when you are naming, we follow the same way of naming. For example, for aldehydes, the name here will be ethanol. The name here will be ethanol. Why? Because we have 1, 2 carbons. 1, 2 carbons, we know it's eth. So the name becomes ethanol. When you are having a ketone like that, we said it must have C double bond O surrounded by 2 carbons. So the name there will be propanone. So it's propane. You see, you can see all of them is from ethane. We're just adding how the name ends. The name for ketone, the name will end with "-one" at the end of the name. We have propanone. Then for carboxylic acid, the name will be, because we have 2 carbons, it will be ethanoic acid when you are naming them. The last one is esters. Esters are made up from alcohols and carboxylic acid. So when you're naming them, you will have, we all know this, CH3, we said is a methyl. CH3 is a methyl. And then when you have 2 carbons, so it will be methyl ethanoate. So that's how you name. So you'll have an alkyl group at all times. The alkyl group is the one that is not attached to the C double bond O. The one that is attached only to the carbon, the alkyl group. You will always start with the alkyl group, then you check the number of carbons, then you indicate the O8 at the end of the name. Now, these alcohols, we have 3 types of alcohols. The alcohols that are called primary alcohols, secondary alcohol, and tertiary alcohols. So primary alcohols is when the carbon that is bonded to the hydroxyl group is bonded to one other carbon atom. So when we are having that, when the carbon that is bonded to the hydroxyl group is bonded to one other carbon, we refer to that as primary alcohol. When the carbon that is bonded to the hydroxyl group is bonded to two other carbons. So this one, OH, is bonded to one carbon. This OH here is bonded to two. The carbon that is bonded to the OH is bonded to 2 other carbons. We say secondary because it's 2. When it's 3, the carbon that is bonded to the OH is bonded to 3 other carbons. We refer to that as tertiary alcohol. So for alcohols, we are saying we have primary alcohol, secondary alcohol, tertiary alcohol. Now, those are our homologous series, which we have said already when we started that we have 9 homologous series. So those are the 9 homologous series that we're talking about. Don't forget them. We will be asked questions based on those 9 homologous series. Now, we have what we refer to here as structural isomers. Remember when we started, we said we are having molecular formula and structural formula. We said there are 3 formulas we must know: the general formula, molecular formula, and structural formula. So what we are saying here, we are saying that when you are given a structure, you must know its molecular formula and its structural formula. So what are isomers? What are structural isomers? These are organic molecules with the same molecular formula. So molecular formula is the same, but what is different is the structural formula is different. So we're saying molecular formula is the same, structural formula is different. Then we refer to that as structural isomers. There are 3 types of structural isomers that we are having. The first one is the chain isomer. If you look at the chain isomers, it's the ones that we're talking about. Immediately when you talk about a substituent, an alkyl substituent, you are having chain isomers. Remember, we talked about butane. But if we are having 2-methyl propane, as we are given there, what we are supposed to do is to first count the number of carbons, which will be 1, 2, 3, 4. Then you count the number of hydrogens, which will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you say this is C4H10. It's the molecular formula. So you must count the molecular formula for all the 2 structures, which all of them will give you C4H10. When you are having C4H10, you know they have the same molecular formula, but what is different is their structural formula. So you will refer to this as chain isomers because they have the same molecular formula. What is different is their structures. Their structures are different. And the other way to know is to give them names. The names must always be different. So that is a chain isomer. So we're saying for chain isomers, all of them, they will have the same molecular formula, but different chain structures. So the chains are different here. Here on this one, functional isomer, they have the same molecular formula, but what is different is the functional group. So we get this between esters. We get this between esters and carboxylic acid. And we can get this between aldehydes and ketones. So this will give us what we refer to as functional isomers. The main thing, you count the number of carbons, the number of oxygens, the number of hydrogens. You write the molecular formula. From there, you check the structures, that the structures are different. Then you are able to identify the functional isomer. The last isomers that we are having, we call them the positional isomers. Positional isomers, they have the same molecular formula. So for all of them, you are saying they all have the same molecular formula, but what is different? On this one, the positional isomers, we have different substituent, different side chain, and or different functional group. So there are three different things there. That's the one you must take care of. But these ones from the name already you know. Same molecular formula, different chain. Same molecular formula, different functional group. Same molecular formula, but different position. Position of what? SSF. Substituent, side chain, and the functional group. So this tells you that you are having these are structural formulas that you are having. So know that we have structural isomers. There are three types. We are saying chain isomer, positional isomer, and functional isomers. We gave you the examples of each of them, but the main thing is that when you get a question, start by checking how many carbons you have in that structure and hydrogens. Now let's look at an activity as we conclude this lesson. There is a question here that says, to which homologous series does the molecular formula C8H14 belong? Now, you will remember when we started, we said we have general formula for CnH2n is general plus 2 is general formula for alkanes. We said for alkenes, we have CnH2n. For alkynes, we have CnH2n minus 2. So you got now to come and substitute on this formula because N stands for the number of carbons that you are having. So we're having 8 carbons. You will say this is C8H2 times 8 plus 2. So you know that if it's an alkane, it will be C8H18. Then you come here, you substitute again on this formula. You say N is 8, so it's C8H2, 8 times 2, which is 16. So the name will be C8H16. Here you have C8, then you know that this H2N, which is 2 times 8 is 16 minus 2 is 14. Then you see is C8H14. So you are able to check, oh, C8H14, these are alkynes. So you are able to choose C. So you see, even when you are doing multiple choice, make sure that you work it out. You are sure of the answer that you are choosing. So when you're choosing C, you are quite sure that that is the answer because you worked it out using the formula for the general formula. Now, the 1.2, the general formula of the haloalkane is, remember, haloalkanes, we said we substitute one hydrogen with a halogen or a group 17, which we indicate with an X. So that will be D. As we move. In question 2, most of the time you're going to get question 2 in this format, where you are given that table. The table is saying, we took this from an exemplar paper. We're saying, question 2 are saying the letters A to F in the table below represent 6 organic compounds from different functional group. What I'm going to take you through here is not necessarily the question, it's the strategy as to how do you answer these kind of questions. So what you are supposed to do here when you are given a table like this one, they said the letters A to F in the table below represent 6 organic compounds from different functional group. So what you are supposed to do is to say number A. You go to number A, you say, what is number A? You look for the longest carbon chain. You say 1, 2, 3, 4, 5. You know that, okay, the longest carbon chain, 1, 2, 3, 4, 5. So you know that when the longest carbon chain is 5 carbons, already you know that, okay, that will be pent. Then you go and look for the functional group. It's a C double bond O surrounded by 2 carbons. You know it's a ketone. So it will be pent. 1, 2, 3. So it's pent. Pent, then you indicate without wasting time. You say pent 3-O. That is the parent name. Then you look for the substituent, because we said always you start with the substituent. So the name will be 2-methyl pentan 3-O because of that. Because you know in the questions they will ask you, what is the functional group of this? You will say, this is a ketone. They will say, what is the name of this structure? Then you have named the structure. The other thing, you come here, you check this one, you say, but 1,1, you know it's an alkyne. You check, okay, this is an alkyne, but what is the homologous series for this one? Is alkyne. What is the functional group? You know, is the carbon-carbon carbon-carbon triple bonds. So you indicate there that you are going to have carbon-carbon triple bonds as your functional group. Just mind me as I repeat this one. So we're saying we have the functional group for this one is a carbon-carbon triple bonds. So when you write the functional group, you'll write it like that, because they can ask you to write down the structural formula of the functional group or the structural formula of the entire structure. So that is the question you'll be expecting. Now, the other thing that you must understand, you will look at this one and say, okay, this one, because it has an OH, is an alcohol. What is the longest carbon chain? Is 1, 2, 3, 1, 2, 3. So you know that it has 3 carbons. You will always number closest to the OH. So this becomes 1, 2, 3. So you know that you have a 2-methyl, it's an alcohol. In carbon number 1, we have an OH. So you will say this is 2-methyl propan 1-ol. So now that is helping you to, when you go to questions already, you will be expecting to say, okay, I know already this is a 2-methyl propan 1-ol. What is this? It's a butane. What is the homologous series? It's alkane. And what is the molecular formula and all that? When you look at this, it's 2-methyl butanal. Obviously, you know butanal. What is the functional group of butanal? That is a homologous series is aldehydes. Then you know that a butanal is 4 carbons with a C double bond H, C double bond O, and an H at the end. So you have a substituent there, 2-methyl. So you are able to go through this table before you answer the questions, so that when you go to questions, it becomes easier, because they will ask you questions that are based on this particular table. So I use this table to indicate to you how to approach the question, to say, before you answer the question, go yourself, draw structural formula, draw molecular formula, and check what you are able to know about, recall about the structure itself, so that when you answer questions, it becomes easier. So without any wasting of time, I will wrap up by saying, remember what we have done today. We have done 9 homologous series. We said these 9 homologous series, they differ from each other by their functional group. We'll differentiate them using functional group. For alkanes, we said it's carbon-carbon and carbon-hydrogen single bonds, carbon-carbon double bonds, carbon-carbon triple bonds for alkanes. These 3, we said these 3, we refer to them as hydrocarbons, because they are made up of hydrogens and carbons only. So we know those ones as hydrocarbons. And we said this haloalkane or alkyl halide, we treat our halogen as a substituent, the same way we are treating, we were dealing with our alkyl. So you'll have to understand that one. To say then, we said you have alcohol, which you said you will see them, they have an OH. OH is a functional group. Its name is hydroxyl group. The name of this functional group is hydroxyl group. Then you have a carbonyl, which we find in ketones. Ketones, we said, is a C double bond O surrounded by 2 carbons. So the name of the functional group is carbonyl. Then we said esters are made up from alcohols and carboxylic, from alcohols and carboxylic acid. So you got to understand that as well. Then we have esters that are made from alcohol, and that we said it's a C double bond O followed by that. So as their functional group. And the last one is the carboxylic acid. Carboxylic acid, that we refer to as carboxylic acid, we said, you will see them, it's a C double bond O, at the end you have an OH. So you got to know all the functional group. And then as I finish by defining for you what a functional group is, so that you understand that a functional group is important, because you're going to use it to identify all the homologous series. So we're saying a functional group, we're saying is a bond. It's a bond. You have a carbon-carbon single bond, carbon-carbon double bond, carbon-carbon triple bonds. They indicate a functional group. We're saying it's an atom. We're having atoms like bromine, chlorine. They indicate a functional group. We're saying it's a group of atoms. group of atoms. So we can group them. For example, when you're having OH, it's a group of atoms, O and H. This group, so we're saying a functional group is a bond, is an atom, is a group of atoms that determines the physical, the physical and chemical, I must write the correct end, and chemical properties of an organic molecule. So that is our functional group. They determine the physical and chemical, which means this, whatever we're doing, it was for question 2. So when you do question 3 and question 4, you will be dealing with the physical properties and the chemical properties that we are saying that is what the functional group determines. So we're saying it's indicated by, it's a bond, it's an atom, it's a group of atoms. What do? They determine the chemistry, or they determine the physical and chemical properties of an organic molecule. So we're saying for definitions, ensure that you get all of them. You get total in definitions is 2 marks or nothing. So you must write definitions according to the exam guideline, as we have said. So this summarizes our lesson, and thank you very much.